Hi, sir. Our group is taking case 5 that is Sea Empress oil disaster. And our group is consists of Chong Feng Qingyi, and Wong Cheng, and I'm Wong Cheng. And these are the contents we are gonna present it later. For the MVC Empress oil spill, one of the most significant maritime environmental disaster in UK history, we will explore the incident's causes, environmental damage, and how it transformed maritime policy, oil spill response, and coastal protection strategies. On February 15, 1996, the single-hull tanker MV Sea Empress ran aground near Milford Haven, Wales, while carrying 130,000 tons of crude oil. Over the next week, approximately 72,000 tons spilled into the marine environment, triggering one of the UK's worst environmental disasters, with damage exceeding £60 million. Today, we examine how this catastrophe reshaped maritime safety. Next is about the safety management of ship operation. For the first one is enhanced navigation and pilotage procedures. The investigation revealed two fatal flaws in navigation. For the first one is pilot error. Is an inexperienced team misjudged the treacherous tides at Milford Haven. And for the second one is obsolete system. They lack of real-time tidal current data. And for a solution is military expert pilots for high-risk zones. Real-time tidal monitoring system installed at all UK ports by 2000. And also the bridge resource management training to prevent cognitive errors. For the next one is improve oil spill contingency planning. When the Sea Empress spilled, Britain wasn't ready. The response took 48 critical hours to mobilize. Kirby and Law's 2010 analysis proved this delay doubled the environmental damage. For the solution is National Contingency Plan, mandate 24/7 standby teams, pre-position barriers and dispersants at all major ports, and also for the satellite monitoring provides instant spill detection. For the next one is advanced risk assessment and safety culture. The Sea Empress exposed a dangerous complacency. Saraftis 2019 research found they had no formal risk assessment for the Milford Haven approach and a culture that discouraged safety reporting. For the solution is formal safety assessment for all major shipping routes, near miss reporting system the reward transparency, and also AI power risk modeling that updates in real time. For the last one is strengthen port state control inspection. Lax enforcement let substandard ships like the Sea Empress operate. NAP's 2009 study revealed only 40% of tankers received proper inspection, and high-risk vessels weren't prioritized. And first solution is Paris MOU inspection now cover 98% of vessels. And risk-based targeting focus on edging single-hull design. And also for the last one is digital records ensure no ship slips through the cracks. Next is the protection of human life and marine environment. First one is the immediate human protection. The 1996 Sea Empress disaster spilled 72,000 tons of oil off Wales, but its true legacy is the life-saving reform that followed. Let's examine how this tragedy transformed marine safety. Responders in 1996 lacked basic protection, so that's why many suffer permanent lung damage. Today, every tanker carries toxic gas detectors and emergency breathing gear. Helicopters now reach casualties in 90 minutes, not 8 hours. This change have reduced responder injured by 80%. Next is the marine ecosystem defenses. The spill single hull tanker was phased out globally by 2010. Modern double hull ships reduce spill risks by 60%. AI-powered drones can now contain spills in 2 hours, compared to 2 days in 1996, providing clean-up huge ecosystem twice as fast as traditional methods. The last one is integrated safety guards. The most profound lesson from Sea Empress was you cannot separate human safety from environmental health. When oil entered the food chain, Welsh seafood markets closed for 18 months. Not by regulation, but because crabs literally dissolved in fishermen's pots. Today's integrated system prevents this cascade. Automated sensors now monitor shellfish bed 24/7, triggering instant harvest bans when toxins appear. Coastal clinics track spill-related illness in real time, and where communities once waited years for compensation. The UK's Oil Pollution Fund now provides emergency payment within 72 hours. Because protecting livelihood is part of protecting ecosystem. The Sea Empress taught us the real safety requires both technology and accountability.
I'm Chong, and now I'll be presenting a series of actions that aim to manage the environmental, financial, and human life risks associated with maritime oil spill disasters. First and foremost, the UK should establish a national marine disaster response center to coordinate oil spill response and communications. The center would serve as the central hub for monitoring maritime risks, deploying containment equipment, and coordination with local port authorities and environmental agencies. Next, in the Sea Empress disasters, thousands of seabirds were affected. A makeshift animal hospital was opened, but over 7,000 birds died. So it suggests to establish a permanent wildlife response centers in oil-sensitive coastal zones with trained veterinarians, emergency holding facilities, and rapid deployment kits for wildlife cleaning. These facilities would enable fast treatment of oil marine animals and birds, preventing a further biodiversity loss. And lastly, the priority is to invest in oil spill detection and monitoring technologies to minimize the reaction time. The UK should use satellite imagery and radar equipped drones for early detections and also implement AI driven forecasting models to predict spill movement. And lastly, link detection system to the Maritime and Coast Guard Agency MCA. So these early detections allows for timely deployment of bombs and skimmers, minimizing the environmental damage and cleanup costs. From a financial standpoint, the government should create a maritime pollution compensation fund. So this fund would be used to cover the cost of emergency response, cleanup operations, and economic losses incurred by affected industries such as fisheries and tourism. So this funding can be sourced from the levies on high-risk vessels, marine insurance contributions, or port charges. At the same time, the UK should mandate all oil-carrying vessels operating in its water to carry the environmental liability insurance. This can ensure that those responsible for pollution to bear the cost rather than the taxpayers. Lastly, the protections of human life and safety must also be prioritized. A detailed national maritime emergency response plan should be developed and regularly tested through joint simulations involving the Maritime and Coast Guard agencies, fire services, environmental agency, and also the health departments. Furthermore, the government should implement enhanced health and safety protocols for oil spill responders. For example, the medical monitoring, personal protective equipment, and proper decontamination processes are critical to safeguarding the health of cleanup workers and volunteers. These procedures should be enforced by trained safety officers on site during any accident.
I am from Cheng. Now I would like to talk about the future recommendation to avoid accidents. To reduce the chance of accidents like the sea and breast crowding, we recommend enhanced training and certifications for harbor pilots. This includes mandatory simulator-based training focused on difficult conditions like strong tide, limited visibility, or equipment failure. Certification should be renewed regularly to ensure pilots are prepared for different ship types and evolving port conditions. Teams coordinations between pilots and bridge crew is also important and must be practiced. For example, in Rotterdam, pilots undergo simulation exam every few years to maintain their license. Then, we suggest applying stronger risk assessment before allowing ship to enter port. This should be based on live data like weather, tides, vessel size, and surrounding traffic. If risk levels are too high, port authorities should delay or reduce the vessels. This also includes confirming tug support and emergency plans are ready. Norway used real-time digital risk system to manage tanker traffic safely, and this model can be adopted elsewhere. The International Safety Management or ISM code is a global standard requiring ships to follow a safety management system. It ensures emergency preparedness, proper operations, internal audits, and incident reporting. Port stage and flight stage must carry out regular compliance audit. If a vessel is not compliant, penalties like detentions or fines should apply. Since the Empress disaster, this audit has been made stricter, especially for tanker. Finally, we recommend stricter environmental enforcement under MAPO NSI, which govern oil pollution. Ships should be checked for discharge monitoring, fuel water control, and having an updated SOPET, gas and oil spills response plan. Violators should face heavier penalties, including financial fines and insurance limit. At the same time, we can reward compliance ships through programs like Green Port Incentive. In the EU, EMSA uses satellite surveillance to track and enforce environmental compliance at sea. In conclusion, the MVC Empress disaster was more than just an environmental tragedy. It was a wake-up call for the global maritime community. It explored the gap in pilotage, port risk management, and spill response, prompting essential reform. Our presentation highlights key lessons that continue to shape safer and more responsible maritime practices today. By enforcing better training, adopting real-time risk tools, complying with international safety code, and protecting marine ecosystem, we can prevent such disaster in the future. Ultimately, it's about transforming a crisis into lasting opportunity for a safer maritime future. That's all for our presentation. Thank you for listening.